We begin with HCF and LCM. Beginners sometimes get confused whether a question is an application of HCF or that of LCM. So we are going to study the two simultaneously, yeah, in the same framework rather than sequentially one after other, right? So let's begin. HCF and LCM are defined for two or more than two numbers, right? So you need at least two. So let's begin by understanding the HCF and LCM are 24 and 36. The first word of importance is F, right? Not the, we start reading it by HCF, but what is important is F, and F stands for factors, right? So we have learned factors. Factors are numbers that divide the given number. So let's take 24. 1 is a factor of every number. 2 divides 24. 3 also divides. 4 also divides. 5 does not divide, right? And we have a 6. 6 into 4 is a 24 from our chapter of factors. Now we know that factors exist in pairs. 6 4s are 24, 3 8s are 24, 2 12s are 24, and 1 24. So these are factors. So let me again write down. What are factors? Factors are numbers that divide the given numbers, right? So 36, 1 will divide, 2 will divide, 3, 4, or 5 will not divide, 6 will divide. 6 as square is 36, again 6 will lie in the center of it. So 4 9s are 36, 3 12s are 36, 2 into what will make it 36? 18 and 36. So these are your factors. As against that, let's look at LCM. Similarly, the key important thing here is M, and M stands for multiples, right? So what are multiples? Multiple table, you have to multiply them. So multiples of 24 are 24 itself, the first multiple, 24 into 2, the second multiple, 48, 24 3s are 72, 24 4s are 96, and so on, 120, and they'll continue, they'll go on infinitely. So there are infinitely many multiples, unlike factors. 36 multiples, 36, 36 2s are 72, 36 3s are 108, 36 4s are, add a 36 to this if you're not very strong with your tables, 144, and these will also go on infinitely. So what are multiples now? Multiples are numbers, let me use a similar language, multiples are numbers that are divided by the given numbers, right? So why I'm doing this is, for me it's crystal clear, this framework. Multiple means to the right of the numbers, larger than the numbers, right? So whereas factors are less than the numbers, to the left of the number. So I'm using the help of a number line. So I don't think so there should be any sort of confusion between whether it's an application of multiple or of factors. If I want numbers which are smaller than the given numbers, it has to be factors. If I want a number which is larger than the given numbers, it has to be multiple. So I find it difficult when people say that I could not identify whether it was an application of LCM, HCF. Therefore, I'm doing. Let's continue. So we have our first words, factors and multiples. The second important word is the common factor. C stands for common. C stands for, in both the cases it stands for common. So I want common. Common to the two list. Oh, so 1 is there in both the lists, 2 is there, 3 is also there, 4, 6. So all of them seem common. No, 8 is not there in the second list. 9 is not there in the first list. 12 is common, 24 is absent here, and so on. And there are no more multiples, right? So what are common factors now? Common factors are that which divide all the given numbers. All the given numbers. Right? So what I mean by that is 8 was dividing 24, but 8 was not dividing 36. 9 could divide 36, but 9 is not present in the earlier list. It cannot divide 24, right? So, common factors, 6 is common, will divide both the given numbers. Right? It's as easy as that. Similarly here, common multiples, the second word, LCM, common multiples. Now this is very easy. 24 is not present here, 36 is not here, 48 is not here. Oh, 72 is a common. 96 not in the second, 102, that doesn't seem to be anything. Hang on for a moment. If I try the next multiple, 24, add a 24 to this, 144, there I see a common multiple. Right? And if you keep going on and on, there are going to be many more common multiples because this list extends infinitely. In fact, if you see 72 is common, 72 into 2 is 144. If you continue 72 into 3, 216 will be in both the list. So that is also common. I hope. So what are common multiples? Common multiples of numbers that are divided by all the given numbers. The importance of all. So for example, if I take a 120, 120 is divided by 24 but not by 36. Yeah, I can do the same thing for 108. Is divided by one of them but not other. But then 144 is divided by both of them. 72 is divided by both of them, by all the given numbers, right? That should be your basic understanding. The word H obviously stands for the highest and the word L stands for the least. These should be the least of your concern. They simply mean there are many common factors. So which one do I take among the common factors? The HCF says the highest one, the largest one, right? So we have HCF is nothing but the largest number. I again write it in bold, that divides all the given numbers, the numbers for which you are finding the HCF. And what is the least common multiple? Oh, there are many common multiples, 72, 144, 216 and so on. Amongst them, choose the least. So LCM becomes nothing but the smallest, the smallest number that is divided by all the given numbers. And these two sentences that I have written here are the language of basic applications of HCF and LCM. Let me hold here and again tell you, listen, when we are talking about common multiples, like in work and so on, we need to take the LCM. I've seen a lot of students worried about LCM. It's not just LCM that I want just a common multiple. A common multiple is enough to get rid of fractions. So don't waste your time on the word least. Even in the applications that we see, I will be playing around with this word least and the highest out over there. So that is not what your focus should be. Your focus should be on, oh, is the number that I'm searching, is it divided by the given numbers or does it divide the given numbers, right? So let's see the language of few application oriented questions.